Permutations, combinations, and the binomial theorem is chapter 11. How many of you guys have heard of these things at all?
Oh, we learned it last year.
Learned a little bit of it last year? That's good.
Oh, not really. No, I didn't really.
Oh, not really. Okay.
Very much.
This is pretty new math for you. I will say that. Which is kind of strange at the very end of grade 12. At the very end of high school, you have new math. It's kind of weird, but it's not too difficult. I know. Deshaun's like, well, it's the same thing as tricky, right? No, not always. It's not too difficult in terms of like calculations, but it can be tricky, and maybe by the end you'll see the difference between those two terms. But yeah, it's new math for you. It's a math that is kind of a stepping stone into the realm of probability. So if you ever take probability in post-secondary education, yes, there's a class called probability, and yes, it is stinking hard. It was like my worst class. It was my most infuriating class when I was in university. I could do calculus all day long, and number theory, and linear algebra, and all those guys, but probability was like the bane of my existence. It was very tricky, which made it felt hard, but it was like there's so many like details that you have to think about when you're dealing with probability problems, right? You have to be. It's not just a case of here's the question, here's how you find the answer, job's done, right? Here's the question. Think about some of the special cases of this question. Think about different things that could happen in this question, and then base how you approach your answer on your brainstorming, right? So I guess my advice to you would be don't try to blast through the assignments doing the same method all the way along, because you might make some careless mistakes along the way. When you get to each question, try to think through what it's asking, think through some of the special cases that might pop up, and then base your approach on that. And maybe that sentence will make more sense as we go along. Okay? For the sake of grade 11, like I said, this is a stepstone to probability, and we'll do a little bit, but for the sake of grade 11, or 12, sorry, this chapter deals with different ways of organizing and categorizing outcomes and possibilities of a certain event happening. Okay? So games that are based on luck and chance, like pretty much all gambling games, poker, blackjack, crib, even slots, all use this mathematics. And gamble people who make casinos and make gambling games use this type of mathematics to calculate the probabilities of certain things happening in their games. And then they, of course, tweak the game a little bit to make you feel like you're doing successful at some points, and that you can even predict what's going to happen. You know, you ever heard of a hot slot machine, where like that slot machine is really scoring every 5 rounds. People are getting a lot of money, so everybody wants that machine, even though realistically the probabilities never change from crank to crank to crank.
So
people just think that the machine is on fire, that it's producing a lot of money, but really it's just a lucky probability. The probability of getting a jackpot on a slot machine is the same every single time you pull the handle.
Do you know if they make machines so that those slot machines so they actually never produce a jackpot?
I hope not.
They just make
There might be.
the whole thing? That's
There
what
might
I
be.
do. I was assuming one.
Have you guys ever played crib?
Mm-hmm.
You know what a 29 hand is?
It's like the biggest hand you can get.
Yeah, it's the most amount of points you can ever get. That hand is so rare, and maybe we'll calculate the probability of it in the next section, but that hand is so rare that I know people who have played crib their entire lives and maybe only seen that hand dealt once. In fact, I heard of a story of a guy who was on his deathbed in the hospital who had played crib all his life, and like one of the last hands that he was dealt while he was at the hospital dying was the 29 hand.
Life's completed.
So I think this math is pretty cool. It does some pretty powerful things, such as like the probability of getting a royal flush in poker is this exactly, right? 1 out of 649,740 hands. One of those will be a royal flush. And you can show that with this type of mathematics, and I'll show you how to do that eventually. Lotto 649, the odds are even worse. This is winning for all 6 numbers, making sure all 6 numbers are right. And Lotto 649, because you have to choose 6 numbers. The chances of getting all 6 numbers correct is 1 out of about 13 million. Okay, and that's exact too, and again I'll show you how to do that. That'll be the next section. But just to give you an idea of what some of this mathematics can do. Okay. So to start off today, I'm going to start with something very foundational to everything you learn in this chapter. It's called the fundamental counting principle. Okay, and it works like this. The fundamental counting principle is basically this. If one task can be performed in a number of ways, and a second task can be performed in b number of ways, then the 2 tasks can be performed in a times b ways. That's the fundamental counting principle. You can do one thing a certain number of ways and a second thing a certain number of ways. The total number of ways of doing both of those things would be the product of the number of ways you can do each of those things. So to illustrate this, imagine in your closet you had 8 sweaters, 5 pairs of pants, and 3 hats. Okay, I'm sure you have more clothes than that, but how many different outfits could you make? Assuming all the sweaters and hats and pants are different.
Quite a few.
Quite a few. Could you tell me exactly?
So it's 8 times 5 times 3.
8 times 5 times 3. Okay? So another way of thinking this is for every sweater and pant you have, there are 3 hats that you could wear. Or for every sweater and hat that you wear, there's 5 pairs of pants that you could wear. And if you had, for every pair of pants and hat that you have 8 sweaters that you could wear. The total number of ways you can do it is 8 times 5 times 3. So that would be 40 times 3, so 120 outfits in total. And that's the fundamental counting principle, and we're going to be using this all day today.